Now, you must be thinking here that what I have done it is nothing but conformational isomers. Now, about the conformational isomers you have studied, I've told you earlier when I was telling you about the types of isomerism, about the conformational isomers. That is, you will be studying that it has got restricted rotation about a single bond. Alright, are called conformation. When there is a restricted rotation around a single bond, all these are single bond, you can see, all these are single bond. Around a single bond is nothing but known as conformations, and different conformations are also called conformational isomers or conformers are said to be as. Different conformational isomers, different, are known as conformational isomers or conformers. Now this particular structure which you are seeing it, what is this structure called as? Is it Sawhorse projection? It is Neumann projection? Or is it what you can say Fisher projections? Or it is dash wedge? It is Neumann projections, which I have already studied, Neumann projections. Here I am showing you the different conformers, 6 conformers, 1, 2, 3, 4, 5, 6, the 6 conformers which you can see it here. They are nothing but the Neumann projections of butane. Butane, we can see butane, CH3, CH2, CH2, CH3. CH3, this is carbon, CH2, then this is another carbon I said you, CH2, and this is CH3. Again I repeat, CH3, this carbon, then this is carbon having 2 hydrogens, CH2. So CH3, this CH2. This is another carbon I said you, Neumann. So this carbon is attached to how many? That is CH2, and this is one is CH3. So in this way we are having the butane. I have drawn butane in another manner also in what you can say Neumann. That also can be done. Now here I want to show you something. What you find is that when it is being rotated, alright, when it is rotated, this particular conformers, when it is rotated, it has got a restricted rotation. Just now I said you, it is a conformational isomers. So what you find is that due to restricted rotation, it develops a torsion strain, we can say, or torsional strain, we can say that it is developed. This rotational, what you can say, this how many degree rotating I am rotating it 60 degree. See, this angle is 60 degree. This one is. So hence, this particular conformer is said to be as what? Eclipsed, or it is staggered. It is known as staggered. You have read it. Staggered means the angle between them is 60 degree, and in case of eclipsed, the angle between them is 0 degree. You can see 0 degree, the angle between them, because they are parallel to each other. They are 0 degree. Do you remember all these things you have studied? So in this way, it develops a strain that is known as torsional strain. Torsional strain, we can say that. When you are rotating it, see I am rotating. This is a 60 degree. Then again it comes here. You can see CH3. Now this CH3 again it comes here. You can see. Same CH3, this CH3, the first CH3, hold it from here, this CH3, 60 degree angle. Alright, you rotate through another 60 degree, it comes here, see here, CH3, clear? You rotate through another 60 degree, it comes here, see? You rotate through another 60 degree, it reaches here. You rotate through another 60 degree, it will come here. You rotate through another 60 degree, it is coming here, in this way. Alright, clear? Now we get as a result 6 conformers we are getting it. It is rotated by an angle. It develops a strain, and that strain, a force it develops. That is known as torsional strain, we can say that. Now we have to understand this diagram. We have to understand. Already I said you, this is your staggered. So staggered here is 1, then 3, and then what you can say 5. Yes, this is staggered. The angle is 60 degree, you can say. Now you can say this, sir, how this is staggered? I'll come to it, don't worry. Got it? Now this is eclipsed. 2, you can see 0 degree. Again 4 and again 6. It is eclipsed. 2, 4 and 6 are eclipsed. You can see here 2, 4 and 6 0 degree. 1, 3 and 5 they are staggered, which is not 60 degree. What you can see 2, 4 and 6 0 degree. 2, 4, 6 0 degree. Sorry. And 1, 3 and 5 they are staggered. We can say. Now 1 is understood 60 degree. It is staggered. Now it rotates to 60 degree and we get eclipsed. So first one is staggered, second one is eclipsed. Remember it. Now third one, another rotation through 60 degrees. So it reaches here. Now this staggered form is known as anti. It is called as anti. The staggered form is where CH3 are at an angle of 180 degree. You can see 180 degree. If I draw a dotted line here, you can see it's 180 degree. It is called as what? Anti. A-N-T-I. Anti. We can say. Now This particular one is, then what is the name is called? The name, this particular, because both are staggered. Listen carefully. Both are staggered. This is staggered and this is anti. Then what is this called then? What is this staggered called? This is known as gotch. What I said you? Gotch, gotch. G-A-U-C-H-E. Gotch. We can say that. So this is eclipsed. This is what I said, anti. Clear? Now again this also is 0 degree. This is also eclipsed. Clear? Now this is again what you can say, gotch. 60 degree angle, you can see it here, 60 degree. I am taking this is 3, understood? One I have to take it constant, so I have taken this one. Now this also is what you can say, eclipsed, but this is called as fully eclipsed. It is known as fully eclipsed. This particular one is said to be as. Clear? So in this way, gotch, eclipsed, anti, eclipsed, again gotch, and it is fully eclipsed. Got it? Fine. This is about the diagram, you understood it. Clear? Out of that, again I say 1, 3 and you can say 5. They are coming under staggered. 2, 4 and 6. They are coming under eclipsed. The angle is 0 degree. They are the different conformers of which particular molecule? Butane molecule I have shown you. Now, I will talk about their stability. Alright, how and which what you can say conformer is more stable here, which particular conformer, and how it is more stable, how to do that I will be saying you now. For that particular purpose I will be drawing a graph. I will be drawing a graph, and by the help of the graph I will explain you that how they are stable. Alright, which is more stable and which is less stable I am going to explain you. Alright, so here I am taking, that is potential energy in the y-axis, and here it is nothing but 60 degree, this is 120 degree, this is another 60, that is 180 degree, this is another 60, it is 240 degree, it is 300 degree, and it is 360 degree. Just I am drawing a hypothetical line here, a hypothetical line I am drawing it from here. Now I will start now. Alright. So that is what I am going to do is that that is 0 degree. I don't have the space. Okay, I'll do one thing. I'll do one thing here. Just a moment, student, because I forgot to write 0 degree. 0 degree I forgot to write. Now it is okay. Now it is okay. Here it is potential energy. Fine. I forgot to write 0 degree. Correct. So from here I will start the graph. You can see I will start the graph. Let me take a blue pen and let me start. So this is your 0 degree. You can see it here. 0 degree. The first starts from. That is, remember the diagram. What is the diagram which I have shown you? So this is the first one. So you can see it here. And 60 degree, the graph will go up. Alright, the 60 degree, the graph will go up. Again, in 120 degree, the graph, alright, what happens is that it comes here. Again, in 180 degree, it goes up. 180 degree, it goes up. You can see. Again in 240 degree, again it comes down. Up and down, you are seeing it. Again in 300 degree, it goes up. And 360 degree, again it comes here. So let me just do the numbering here. This was your 1. This was your 2. 60 degree, 2. This is your 3. This is your 4, this is your 5, this is your 6, this was not there. Of course, it will rotate, it will complete the rotation, it will reach again to the same diagram, that is 1 only, that is 7, I have numbered it. Because 360 degree I have taken it, so I have numbered it. So 1 was, now you see the energy here, potential energy. Here, see, It is not the lowest. The potential energy lowest is in 3. It is in 3, the potential energy is the lowest. You can say that. In 3 it is lowest. So hence this is known as what? What was the 3 called as? It was known as anti. So anti is having the, what you can say, the maximum stability. Anti is having the maximum stability. That is number 3 is your anti, which is having maximum stability. I am writing this in the decreasing order of stability. Decreasing order. So this is the maximum stability. Why? Because minimum energy. See the potential energy, you see the lowest. If you want, I can make it still more clearer. I can lift it up this one here also, so that it will be more clear to you now. Now you can see very clearly. See here 1, the energy is more compared to 3. Now next is, so it is the maximum stability, the anti, we can say that. So what was your 1? 1 was nothing but Gauch. Got it? And what was your 2? 2 is nothing but is your eclipsed. So what you find is that anti is the most stable compared to what? Compared to what? Compared to is Gauch. Compared to Gauch, we can say. Compared to what? Again, Gauch is stable. This is Gauch, na? It is more stable than this because energy more, stability less. Mind it, energy is more. See here, energy is more, stability is less. So it is eclipsed. And the last one, of course, will be fully eclipsed. Fully eclipsed. We can say that. So 3 is your anti, you got it? Fine. Now this is your Gauch. So let me write in Gauch, that is your 1. You got it? Now next is 6. This 60-degree angle is your what? That is nothing but eclipsed. So here it is 2, I have written it, eclipsed. Again 3 is anti, already I have written it, you can see. Let me write in red because all I am writing in red means let me also write in red this one. Fine. Now this is 2. Clear? What is that? No, anti is what? Anti is 3. Anti is 3. 1 is your Gauch. Sorry, 1 is your Gauch. 2 is your eclipsed. Sorry. Now next is after that 4. 4 is again the energy is more. 4 is what? 4 was eclipsed. So it is eclipsed. 4 we can say. Now fifth was again it is nothing but Gauch. Got it? And 6th is nothing but fully eclipsed. This is your 6th we can say. And 7th is 360 degree again, which will come back to the position we can say. Clear? So the maximum stable was your anti. So anti, then Gauch, then eclipse, and fully eclipsed. This is the energy diagram. Energy is inversely proportional to stability. So stability is anti is more stable than Gauch, then eclipse, then fully eclipsed. I have explained it in this way. You can see the Gauch is what you can say is more stable because energy is what you can say, but it is not stable than that of anti. Anti is the most stable. These are the Gauch we can say, and these are the eclipsed you can say. This is fully eclipsed, these two are eclipsed. Energy is maximum. I hope you understood the particular diagram, the stability about the different types of conformers, so to say. Thank you.